Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Kirk Gray.
And this is Fred Schwenkberg. Hey, Kirk, it's been a
Hey,
while.
Fred.
Glad to talk to you again.
Yeah, it was a good summer, and it's good to have you back now that Labor Day is over with.
Yeah, the class ended, and my calendar is not completely open, but it's open way cleaner than it used to be. So I'm glad to have time to record again and catch up and all that good stuff. And one of the questions, I think I actually was on LinkedIn, and I forwarded you that question about somebody was trying to convince their team to do HALT, but it was late in the program and they had limited time to make changes. And I'm like, Kirk might be a better answer for this one. So hopefully he gave him some good info, but I thought it might make a good topic to chat about here.
Right, and I think I did discuss with that or have a online chat, a dialogue going on with him. But I believe him or her, and I believe it was the fact that they had already had established that there was some field issues and some issues that they were working on to fix, and that he was still encouraging his management to use HALT, and his management saying, well, we kind of know what a lot of the problems are, and we're working on those right now. And I kind of started to agree, with his management that, yeah, he's not going to get a lot if they've already got some field data and they've already got field problems. And I've had a client that's done the same thing, that they've been doing testing. They've had the units out in the field for a couple of years, and then they bring me and ask me to want to do HALT on this already established, pretty well known issue. And the things I found out were that there was some very low margins, but that already had appeared in the field.
Yeah, they already discovered that. Yeah.
Right. And they said, well, we can't. I said, well, you're top of the range of this particular function that you need to have done. I mean, the biggest pressure to close this valve. And he said, yeah, we're at the top. He says, we can't provide any more. And I go, well, but that's probably what one of the problems is in your Paretos, and that shows up. And they just kind of, I kind of fell away from them because they really weren't working on a new product, and they didn't. They already had plenty of field problems to work on, or they had decided they weren't going to change them, that they were just going to go with the established failure rate. And
well, I think it doesn't matter what you're proposing to HALT or anything.
Right.
If they're not going to make any changes, well, then why bother?
Right. It's a waste of time.
In
fact, that's the whole point. And one of the, common things in HALT is everybody says we do it, but they don't make any changes. They find things, or they don't go to a limit, an empirical limit, and establish a benchmark for the next product and for a general distribution of their strength of their products, of their, a small sample group. Like, what is the range of operating limits? Is it?
Well, but I think being late in the program, the biggest hurdle is, can you make any changes? And if they say no, then it's a done deal. But if it's late in the program and you don't have that field data, you got a handful of prototype failures you're working on, then I think it starts to be a little bit grayer. It's no pun intended here, Kirk. Last name Gray.
Yes.
It's a
gray area. Yeah.
Yeah, you might speed up the process of finding defects. If you don't have a robust bunches of prototypes and you're doing all kinds of stuff with them and being on benches and you're running through the paces with them, I find that even though people don't call it HALT, is you get your first prototype back or your first mock-up back and it doesn't work. All right. You just learned something.
Yeah.
And you go
every
fix that.
failure is gold. Yes.
Every failure is gold. But what happens though is they go, oh, we got 10 failures. We got to go fix those. All right. That was it just sitting on your bench.
Right.
The customer is not going to put it on your bench and try to use it. So if you fix those, you're not looking hard enough.
Right. It's got to make specifications, whatever, 0 to 32. It's the range of operating
Temperature,
specific.
vibration, it's going
Yeah,
to be
before you go
like in the
right.
customer's hands. Yeah.
Exactly. Yeah, right. And so you got to establish that first and make sure it's robust on the bench sort of, and that you can make more than five without one of them failing.
Hmm.
Um, but at the
So that
same
points to that there's a point where it's too early to do halt. You don't even have a design that works yet.
Well,
That,
right. If it's got a bunch of spaghetti, we called it, on,
mhm.
jump wires and temporary fixes on the board, that's not a good.
Not a
You can do
candidate.
mechanical testing. I mean, I wouldn't do vibration, but you could do thermal just to
Hmm.
see what the range of operating capability is, strength of the range. But at the same time, the first thing you need to establish is where are these problems, where are the failures being generated from? Is it a marginal design, or is it actually process control in manufacturing that's
Yeah.
an issue?
Yeah.
And, if you're talking about process control, well, you focus on the process and you might do some screening, which is, of course, always combined stresses, monitored short periods of time to induce as much fatigue damage as rapidly as possible within the boundaries of safe, as you've established with your safety of screen,
Yeah.
uh, process in the halt process. And that should be your way of finding more of these time related latent defects from manufacturing.
Yeah.
Then, so
So that's another reason to do halt late in the program is to set up to do the process screening if you know that that's where the issues are. So you got to have some
right,
knowledge.
right,
And it's
right,
not just that, oh, we found plenty of things and now we're going to ramp it. And like, well, how well do you know that process? You know?
right. But, if you got a marginal design, you may have very limited range to be able to do a combined stress screen.
Yeah.
So, yeah, yeah, you definitely do halt to establish what the safe parameters or what the limits are to do a HAS, which are reduced from the
Well,
uh,
and that
operating
sounds
limits.
like the this particular question was is they were kind of running at the margin on their product. And it was like, so there's if they wanted to even screen that, there was no room for them to push it.
Right. And why is that? Because most electronics are pretty capable and, in fact,
Yeah.
operate well beyond what most people think they can. And, in
Yeah.
fact, what they're designed for. You've got to have margin in every product, every component, everything to be able to establish mass manufacturing capabilities,
Right. When
and
you
not be
run at the edge of
right,
stuff, then it's you consume that margin, and now you
right,
got no room left to screen out the bad units. You have no
right.
leverage on that system or that
Right,
process.
right. And each one will be, a wounded warrior, a wounded potential failure in the field if it doesn't have margin. You're trying to do screening without knowing where the safe limits are, or where you're really doing serious fatigue damage or serious
Yeah.
damage to it. So, HALT is always the precursor to a combined environment rapid HAS screen, uh, if you want to establish the right empirical way of establishing a house.
Right. So back to the question though, it's so if it's a process thing, that's a good reason to do it. If you're going to make changes based on what you find is good. I think the
Right,
other factor is that yeah, you got things to work on. Is what I always look at, well, when did you find these things? When did you find these issues? And oh, we found them last week when we turned on one of our systems. And I'm like, okay. If you're still finding an increasing number of things to go fix, those are, I think of it as the analogy of the rocks in the river, right? The boulders show up first. And
right,
as the water goes down, you find more and more issues.
right,
And halt helps you drain that river quicker and find more stuff.
right,
And so it's if the rate of discovery of problems is increasing, I think that's a strong argument to do halt to accelerate the finding the remaining issues. And if you've been working on this project for 6 months and it's really knocking down the problems and new ones are not cropping up to take their place, then you probably have sorted out a good number of them. It might only be benign. You may not have gone to the limits of where your product is going to be used, which is another argument to do it. But it's, I think your original answer in the discussions with him is what's the context? What do you know, don't know? What kind of issues are you
Right,
trying to solve?
right,
What areas are still unknown or you're not sure if what's going to happen there or whatever? It sounded like they really knew quite a bit already,
right.
and Halt really wasn't the right fit for that particular moment.
No, I would say that Haas might be though, and that
Hmm.
would require a halt to be done before the Haas if you want to if you want to maximize the strength of the Haas screen,
Yeah.
you have to establish that. So yeah, it definitely, goes back to the root cause and where are these problems coming from. If you're trying to screen out one of your vendors, subsystems or whatever,
Hmm.
which may be what you do instead of trying to go back to the vendor because you're only buying 1,000 and he's making 1,000,000 and you're buying 1,000. I mean, he's not going to change his sign. But you need to establish where, what.
You give them enough money, they will, but
Yeah,
but
yeah.
yeah, and setting up a screen just for a subsystem is way, I find way more effective than doing it once it's in your system. That's a pain.
Right. If that's the problem subsystem. Right.
Yeah.
Yeah. But then, trying to do corrective action so that that's eliminated, which is the whole goal, is you find out the root cause and say, okay, we've got a problem with our reflow machine here, or we've got a problem with this component vendor,
Yeah.
like our crystals we've talked about in the past and other
Yeah.
things. Um,
But I find it's a whole lot easier than going back to the vendor saying, "Hey, it's not working. You need to make them better." And they go, "What? What better?" I find it always better to, part of the halt process is just do the failure analysis, really understand it. And then you have something to talk to them about, saying, "Hey, this part here is not being glued properly, and that's why this crystal is breaking." And how'd you know that? Well, I looked at it, carefully.
Amazing, isn't it?
Isn't
Yeah,
it
we
amazing?
looked at it, but I also, the whole thing. One of the things I feel is a benefit of Halt and establishing a benchmark is
Hmm.
on the fundamental limit of technology. What is the capability of this product if it's built,
Hmm.
if it's well centered? What is the best one you have out of 5 samples? What is your highest operating limit on one of them?
Hmm.
And
Hmm.
is that far from the lowest? The one that has the lowest operating limit? Is it a 30-degree difference between, the best, high temperature at 110, and then you have one sample that's only at, can go to 70?
Yeah. Then you got a different problem. That's a clue that something else is going on. The variability is a problem.
Right. The variability and understanding that. But if you don't go to those limits, if you don't
Hmm.
actually go to where the products is like, y- blue
If you
screen of
stop all of
death,
them at 50, if you stop them all at 50
yeah,
degrees,
you
then
don't
you
know.
learn anything.
You don't learn anything. That's what I'm saying is that people want to stop and say, and I've had the same thing happen at a vendor site saying, oh, 80 degrees is high enough. Well, they all went to 80 degrees. And I said, no, you don't understand. Some of these can go beyond 80, and let's find out what the strongest one is, and then we'll see what the distribution is. And they saw quite a significant distribution. But the one component that was failing, they knew about. They actually knew from previous field experiences. The guy almost immediately went to the parts bin and picked out the same. I think it may have been some FET or something like that. I think it was a
Hmm.
FET that it was failing. They already knew that. That's what's so funny is they already know some of this stuff
Yeah.
because
Well, and most
nobody wants
design
to fix
teams,
it.
yeah,
Yeah.
lots of design teams already know it. And goes, oh, that'll take us a week to redesign this unit or find another supplier or whatever. And so,
Yeah.
but the failure rate's okay. So,
Yeah.
yeah,
5%, they can handle it.
yeah. And that's, I don't
Depends on the
know.
industry, as you've talked about in the past. And some can tolerate a greater failure rate than others.
Well, it's, the final arbiter is your customers. If they like, well,
Right.
this isn't
Right.
working for me. God, I'm going somewhere else. They'll
Yeah.
vote with their feet at some point.
Yes, that's true. And that's the bottom line is making a business case for these things. And it's sometimes very hard to do, but you could say, what also this person, if they, would establish that they would have found these things that are occurring now through the halt process. They would have seen those weaknesses come out
Yeah, months
then they
earlier.
months earlier, and then they know what the cost is to the company for this current failure because they have
Hmm.
a field history, parts replacement, maybe a service guy having to go out, and they can calculate that. And then
Yep.
that's where you make a business case and say, okay, it cost us about 200,000 for this chamber, which we'd amortize over 5 years, whatever. And so this is kind of what it costs per year in supplies. And this is what we'd be saving because this is what, and if it's doesn't make sense as a business case, then
You don't do
yeah,
it.
you're not
Well,
going
I've
to.
also found that, changing the failure rate is one thing. Uh, some program managers really like Halt because it finds the issues sooner and in the program, so it's less expensive and quicker to make
Right.
changes, as opposed to finding it a week before you launch, and
Hmm.
then all of a sudden you're delayed a month, and now that really costs you money. And you already have
And you've
suppliers
got
locked in,
tons
you
of
got
right
products already made, and
parts, parts, so stocked already, and that it's
that gets
kind of
pretty expensive
you've
real
really
quick.
you've already
Yeah.
invested, right? You've already invested in most of the product. So, but then you're right about it's tricky where to do it in the prototype stage. But I say easily if you have even a breadboard, I think you can do thermally. You just got to be careful what stress you're
Hmm.
using.
It might even be just power. Early on, especially when you have like a power supply or a
Right,
power system of
right.
some sort, is put it on the bench and use a variacs and stuff to go 80 volts, 90 volts, 100 volts, go low,
Right,
go
right.
high, do dropouts, brownouts, all those kinds of things, spikes, stuff like that. Really
Hmm.
give it a taste of what the real world is like, of all the noise that's on our electrical lines, and see how it does.
Right,
That's, to me, is halt. It's push the boundaries of, will
right,
your power supply survive, or your power units in your system survive the real world electricity coming off the wall? Because it ain't flat. It is not 120, 60 hertz all the time.
right. Yeah, do that on the bench and then put it in a chamber and do the same
Put
thing
it a
with
little higher
with
temperature
different
and a little
temperatures.
lower. Yeah.
Yeah, yeah, and see where the limits are. And of course you're going to buy a lot of components, probably subsystems like power supplies that are quite common and from a vendor. And it's a nice way to compare the strength of vendors or the capability of
Hmm.
vendors or what the margins are on different power supplies. And I've seen and have documented quite significant differences when we were doing power supplies at
Yeah.
Dell, as far as their capabilities, a range, what their operating limits were. So, you pick one that has the most margin if it's all the same
Yeah.
price,
Yeah. And
you know.
yeah, no, I get it. And but I think our final conclusion is that, yeah, we say do halt early and often, and make sure you think through context of it, the business case for setting up a
Right.
chamber and running this, or even just renting one and at a lab and run a few samples. You're probably going to learn something. Yet, when you're late in the program and the death knell is you're not going to change anything, there's very little value of running a halt unless you are looking ahead to your process control type stuff, the screening. Other than that, it's
Right.
do it as early as you can and do it on the areas that you have the most suspicion of. You don't have field data on it. You don't have any history with these vendors or components or subsystems, but get it in the system. Don't try to convince your organization to do it 2 weeks before you launch and you already have a laundry list of things you got to go fix. It makes it tougher to make the argument there. Uh,
But yes. I think there's also the case of doing it to show that you could have found these things sooner and making a business case
Yep.
for it, since you already have the field cost and the field data, and so that the company will invest, because you can't put in a chamber overnight. It takes, months to put in the liquid nitrogen and other things, compressors, air compressors for the pneumatic. It takes a while to set up a environmental
Hmm.
lab. So, if they don't have one in-house, you could use an external,
A lot
but
of
I
people
think
do until they prove it to
a lot of
themselves
people
that it's the
do,
right thing to
right.
have.
Right, and show that, hey, look, we would have found these things, and we would have saved this money that we're out spending at our customer. And of course, the biggest cost is loss of customer loyalty, or
Customer satisfaction type stuff.
perception to
Yeah.
customer satisfaction. That cost them much more in lost sales and future revenues than the parts and service that of course they're certain. Yeah.
Yeah.
Anyway, so that's another reason to do halt, and it's always a case by case basis. But bottom line is understand where your failures are coming
Yeah.
from.
Yeah. So anyway, that was the question we got, and I knew I had your name written all over it, so I sent it over to you. So I'm glad you
Okay.
chatted with them. And but anyway, if you're listening to this and you've got a question, let us know one way or the other. We'll get it into one of our podcasts, one form or another. Yet we'll try to get you an answer right away. You can head over to accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us there. And we have Kirk and I and the other hosts of the show are available through LinkedIn and our about pages on the site. So plenty of ways for you to get in touch. Hey, I actually remembered that closing line. Thought I was wondering if I was going to have to write it down someday.
That's right. Is this is this your
It's
first
first
podcast since
podcast
you've
since May.
okay. Well, I'm glad I'm get to be entering you back into the speaking of reliability. Although I have enjoyed the other, I've listened to Diane and I guess Greg and
Yeah,
others talk about subject. I find it pretty
yeah, yeah.
interesting. In fact, I would like to get. I wish we could do a group chat that we have more than just you and me and maybe three or
It'd
you
get
know.
out of control real quick. You know that.
Oh, I don't know. I think we'll get it. I think we could get a three-dimensional
Yeah,
perspective, maybe.
we could do that. We could give it a try. All right.
Okay.
Well, thanks, Kirk. We'll
All
talk to you
right.
again soon. Take care. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.